In chapter 11, we're going to look at what is called chi-squared test, and we're going to look at three different scenarios for chi-squared test. And we start off with a hypothesis test that's already familiar to us. In chapter 9, we looked at in chapter 10, we looked at two populations. Each is a proportion population, meaning that you have a population proportion for population 1, population proportion for population 2, pi sub 1, pi sub 2, and we want to test whether the two pi's are same or not. Now we're going to use, and in that chapter 10, we used a z-test. So now we're going to use a chi-squared test for that same problem, but it's going to look a little bit different. And the reason why we want to look at chi-squared test is if it is a chi-squared test, we can extend it to not just two population proportions, but population proportions from several populations, not restricted just to two groups. And then we take that chi-squared concept and extend it further to what is called contingency table. So here are the three files that you have for the chapter: the PowerPoint file, the formulas PDF file, and the Excel shell file, which you should download and work with the problems along with me following the tutorials. Okay, in this chapter you'll learn how and when to use chi-squared test for contingency tables. The contingency tables is the last concept. We're going to start with the two population proportions, extend it to multiple proportions, and then end with contingency tables. Okay, so we'll talk about contingency tables more in a little bit. Okay, so here here is the hypothesis that we already tested in chapter 10. Okay, pi sub 1 and pi sub 2. Now this is what the test statistic is going to look at. So here f sub 0 is the observed frequency that we see in the sample for each category. We'll look at what each category means in just a second. Now f sub e is the expected frequency if the null hypothesis is true. If the population proportions are all the same, what is the frequency that you expect for that given cell? So you have bunch of observed frequencies and expected frequencies if the null hypothesis is true. Then we can compute the chi-squared statistic using this formula and then compare it against the chi-squared table value. Okay, and for that chi-squared table value, okay, now chi-squared is like an F table value. So chi-squared again is because of the squared value. You have only positive values for chi-squared, and you have to have only the right side tail. Okay, so we will use either the table in the back of the chapter, or we can use chi-squared. The function in Excel is CHISQ, chi-sq, dot INV for in table value, dot DIST for p value. So this is what the distribution looks like, the chi-squared distribution, and alpha goes in the right side tail. So do not reject, and you reject the null hypothesis in this if it is greater than or equal to the critical value. So this is the general format. So for all the three different scenarios that we're going to look at, the decision rule is going to be the same. So chi-squared, alpha, right side tail, that's your critical value, and you can also find the p value using the chi-sq dot dist function. So we look at all of those in the Excel example.